In this video, we'll create a raycast in BabylonJS. Raycasting is the process of creating an invisible line that can detect other objects. They're commonly used in first-person shooters to detect objects and player characters when firing a weapon. We'll mimic the effect of shooting a paintball at a sphere that will dynamically place a decal at the hit point while applying an impulse. So let's get started. Okay, we're starting off in Visual Studio Code in a class called Raycasting. Now, raycasting does not require physics to work, but I'm going to use this in conjunction with a couple of physics imposters. So I do have ammo already imported here. We are going to use a couple of physics imposters, a sphere and the ground. At the very top of this class, I have a new variable called Splatters. We're going to use a couple of new textures for displaying a paint splatter effect on a sphere whenever we left click on it. We're going to use raycasting to determine where exactly we're going to be displaying that specific material with a texture, and that texture is going to have a decal associated with it. Now, if we take a look at this one that I have opened up, this is what it's going to look like. We have a couple in here that we can use. So we're going to use that in conjunction with our PBR materials, and we'll take a look at how that works with a decal in a moment. Again, I have a create physics method. That method is going to be used in conjunction with the physics imposters. So let's take a look at that real quick. In here, we have the create imposters, and we're setting up our physics. Again, we're using the prototype level from before. And in our create imposters, we're using the ground as we did before. And now we also have a sphere. So we're going to use the sphere for the raycasting aspects of this. What I'm going to do is I want to be able to go over how to create a raycast that we can then use in conjunction with the sphere imposter. So when we hit the object, we're going to apply an impulse to this object. And we're also going to be going over how we can apply a texture or a decal to the sphere whenever we hit it. So what we're going to do first is I first want to set up the textures. Then we'll take a look at the raycasting aspects. So for the textures, I'm going to create a new method for this. I'm going to call it create textures. Okay, the way this is going to work is that we're going to create a total of 3 different materials. If we go up to the very top, this is a PBR material array. When we create something called a decal, it's going to take a material. So I want to randomize the material that we're assigning to that decal every single time that we're going to create that splatter effect. So let's go down in here, and we're going to create a total of 3 materials, 1 for each of our textures. Now, this will be a little bit tedious. There are better ways of approaching this, but this will make a bit more sense as we're going through this. So we're going to create 3 materials, 1 for blue, green, and then orange. And then we need to create a couple new things with this as well. So let's start off with our first material. So const blue, this will be a new PBR material. Okay, I'm going to copy this and I'll duplicate it a couple more times. And we're just going to call these orange and green. Okay, so we created just the materials. Now we need to go in and we need to assign a couple of things with this. So we need to create a single material for the blue, green, and orange PNG files. And then we need to also ensure that we're using the transparency of these textures. If we take a look over here in the example, this checkerboard pattern means that this is a transparent texture. And then I just want to see the color portion of this texture. So we're going to say blue.albedo texture. This will be equal to a new texture. And those textures are found in the textures folder of my public folder. So // textures / and then we want to assign blue.png. Once again, I'll copy that and we'll paste it a couple more times. One other thing we need to also ensure is that we set the roughness back up to 1. So let's do that up here right above the textures. So blue.roughness equals 1. Again, I'll copy this. And this will be orange. And this will be green. Okay, now with this, we also need to ensure that we're using the transparency like I mentioned before. So again, we're going to say blue.albedo texture.hasAlpha. And we need to set this to true. Again, I'm going to copy this. As you can see, this is a bit tedious. We could probably use a loop of some sort, but this will make it a little bit easier to read as well. Okay, now we need to adjust the Z offset of each of these materials. And the reason why we need to do that is because you'll typically find that if you place this on a decal, if we use each of these materials on a decal and that decal is placed on an object, you're going to run into something called Z fighting. Z fighting is where you see that texture flickering in and out because it's super close to the surface of that object. So it doesn't know what to render out, whether the texture or the object behind it. So a way to get around that is to modify the Z offset of the material to be a little bit higher above the surface of that object. So we'll do this for all three of these. I'm going to say blue.z offset. And we want to use a negative value for this. Remember, a negative value is going to move it closer to the camera. So we just need to go with a very small value of negative 0.25. That'll be enough so that we don't get that Z fighting effect. And again, we need to do this for the orange and the green as well. So let's add those in. Okay, so now we have everything that we need for our materials. We created the materials at the very top. We've adjusted the roughness value. We've assigned albedo textures to each of these. We've adjusted the alpha value. That way we can use the alpha of those textures. And then finally, we adjusted the Z offset so we don't get any kind of Z fighting. Now we need to use our array from up above. We can store them in the splatters array. So I'm going to say this.splatters equals, and we'll create a new array. We'll initialize this as an array, and I'll say blue, orange, and green. All right, so now we have an array of materials that we can use later on. Make sure that we call this up above. So I'm just going to call this in the constructor right after we create the environment. I'll say this.create textures, just like that. Okay, so now we're going to take a look at creating a raycast. And with this, let's kind of discuss what a raycast is. A raycast is essentially an invisible line within our game. Now, with this, we have a couple of things that we need to assign to a raycast in general. So a raycast has three distinct points. It has an origin point, so where it starts off. We have a direction, so which way that we're pointing that ray in. And then we have a length, so how far out does that ray extend? Now, raycasts are typically used for things like hitscan weapons. If you played any kind of first-person shooter like Call of Duty, you may be familiar with the term hitscan. Hitscan allows us to basically create the effect of shooting a weapon and then using a raycast to detect whether or not we've hit something, and then displaying something like a bullet hole texture at that point. Or if you hit an enemy character, maybe you deduct their health, display a blood splatter effect, something of that sort. So a raycast can be used for hitscan weapons. It can also be used to detect distances to other objects. We're going to be applying a raycast using the camera. Now the camera is going to be the origin point, and the direction is going to be the direction the camera is facing in. Now, where I click in the scene, that is where we're then going to be displaying the end of that raycast. So think of that as the length. So let's take a look at how we can set that up. Let's create a new method called createPickingRay. Okay, at the very top of this method, we need to create a ray, and I'll call it ray as such. And we're going to use the scene. I'm going to say this.scene.createPickingRay. And with this, we need to provide an X and a Y value. Now, the reason why we need to provide this is because whenever I left click in a scene, we're using the X and Y value of where I clicked in that scene to determine where we want to place the endpoint of that ray. So the X and Y are going to be based off the coordinates of our screen. So there is an easy way to determine these. You can say this.scene dot, and then let's look for X, and you can see we have pointer X. Now, pointer X is the X-axis, so the pointer is my cursor, and where I'm going left and right, that is the X-axis. Up and down is the Y-axis. So we need to provide the Y-axis as well. So this will be pointer Y. Next, we need to provide a matrix. So we need to say matrix.identity. Okay, and I don't believe matrix actually got imported, so let's make sure that we do import that. Otherwise, we're going to have an issue with that. Okay, and then after the matrix, we need to provide the camera. So let's see if we have a camera at the very top. We do. So this will be the camera that we're using. So we say this.camera. Okay, so we created the ray. Now, anytime I left click in a scene, it's going to get the X point and the Y point and determine where we want to place the endpoint of that ray. Now, the ray itself is not actually going to do anything. We need a way to check to see whether or not we actually hit something with that ray. So we need to create a new variable in here called raycast hit. So const raycast hit, and I'll set that equal to this.scene dot pick with ray. We need to provide a ray, and that's it. Now the raycast hit will allow us to get information like whether or not we actually hit something with our raycast, and whether or not we actually hit something that has a specific name and things of that sort. There's a lot of information that we can get from the raycast hit. So what we're going to do first is we're just going to create an if statement down here that says if raycast hit, and if we look, we can see that we have a property called hit. This is basically just a Boolean to determine whether or not we actually hit something with our raycast. So what we're going to do here is we're going to say if we actually hit something with our raycast, and I'm just going to console log raycast hit something. Okay, pretty simple. And again, like I mentioned before, we want to utilize the raycast whenever I left click in my scene. So right above all this, we're going to create a this.scene dot on pointer down. So if I left click, right click, or use my middle mouse, basically any mouse button, I can then create the array and determine if we actually hit something. So let's make sure that we call this up above. Okay, this.create picking ray. Let's jump back into our browser and let's see how this works. Okay, in Chrome, make sure that you do have the console opened up. Now, if I left click in here, let's say I click on the sky, I'm not going to see anything appear in here because the sky is not actually a mesh that we can detect with our raycast. But if I left click over here or over here, you can see that we do see a raycast hit something. Now, this is a very generic hit. We're just checking to see whether or not we actually clicked on something that is a mesh. I can click on this guy, and you can see regardless of what I hit, as long as it's a mesh, it'll say raycast hit something. Now this has a physics imposter, so does the ground, but it doesn't really matter in this case. I can click all these objects, and you can see it says raycast hit something. So now that we know that our raycast is actually working, let's take a look at how we can actually utilize this and add some decals to this sphere, and then also take a look at how we can apply an impulse to this object whenever I left click on it. Okay, going back into our code, we're going to use our if statement now to create a decal if we actually hit the sphere, and only the sphere. So if we hit the sphere, we're going to create a decal dynamically. We're also going to be randomizing what material gets applied to that decal, and then we'll see that decal being applied to the sphere. So in here, I want to check first off if we hit something, and we're going to add in the double ampersand, and if raycast hit dot picked mesh dot name equals, and we're looking for sphere. Okay, that is the name of the sphere that has the physics imposter. Now, if both of these have been met, I then want to create a decal and apply it to the sphere. So I'll remove the console.log. We're going to say const decal, and this will be equal to a new decal, which is part of mesh builder. So mesh builder dot, and we're looking for create decal. Now the decal is basically just a mesh object. Think of this as a plane that has a texture associated with it. We're then going to be creating this dynamically and applying it to the sphere. So let's provide a name for this. I'm just going to call it decal. The source mesh is going to be the object that we hit. So the source mesh in this case is going to be our raycast hit.picked mesh. So I'm just going to copy that. Okay, and if you hover over picked mesh, you can see this is an abstract mesh. So that is the object that we hit with our raycast. Next, we need to provide some options. Now the option we're going to provide for the position, let's go ahead and write this out. So position is going to be the raycast hit dot picked point. Let me go ahead and just say this real quick. So the picked point is a vector 3. That is the exact point that the raycast actually hit the object. So that is where I want to place the decal, at that specific hit point. Now, one of the other things we need to provide after this is something called a normal. So normal will basically allow us to determine the direction that the face of that object is facing in. So if you have a sphere, there may be different parts of that sphere that point towards the camera, some that point directly up, some that point away from us. And we want to ensure that the decal is facing in the same direction. So the normal for this is going to be the raycast hit dot, and we have get normal. Now with the get normal, we can provide the use world coordinates, and we'll set that to true. Okay, this will allow us to get the normal of the object that we actually hit. Next, we'll provide a size. So the size is just going to be a basic vector 3. So I'm going to say new vector 3. and I'll set it equal to 1 by 1 by 1. All right, so we're not done yet. We created the decal. We essentially created a mesh, but now we need to assign a material to this. I'm going to say decal.material is equal to, and now we're going to randomize what material gets assigned to the decal. So for this, we're going to reference our array up above. That is going to be the splatters array of our PBR materials. So I'm going to say this dot splatters. Then we need to provide an index. So which one do we want to use? Now I want to randomize the materials like I mentioned before. So we're going to say math.random. Now math.random will give us a random number between 0 and 1. This is not going to be a whole number, so we are going to use something called math.floor along with this. But what I want to do is I don't want to go between 0 and 1. I want to go between 0 and the length of the array that we're using, which is this dot splatters. So the way that we can get that is by using a multiplication. So math.random times this dot splatters dot length. Now the value is going to be between 0 and the length of this array. Now remember, this is not going to be a whole number. So if we get, say, 0.25, we are going to get an error because we can't say, I want to get the index of 0.25 of the splatters array. So we need to use math.floor for this. Okay, so math.floor will give us a whole number from whatever we get out of this. Okay, so math.random times this dot splatters dot length. This may be a value of 3. So between 0 and 3. And then we need to use math.floor so that we get a whole number from this. So 0, 1, or 3. All right, so let's just take a look at what this does for now. We are going to come back and modify this, but let's review this real quick. We're creating a decal dynamically every time we hit a mesh called sphere. We're creating a decal. We're applying it to the picked mesh, which is going to be our sphere. The position of where this decal is going to be placed is at the picked point. So right where the Raycast actually hit something, that specific point. The normal is going to be the normal of that object that we hit. And then the size of the decal will be just set to 1 by 1 by 1. Then we assign a random material to that decal based off the splatters array. We're using math.floor to give us a whole number between 0 and whatever the length of the array is. Now I could also put times 3 or whatever the length of the array is right now, but this will be a little bit more dynamic. So if I want to add more textures or more materials, I can just use this as is. All right, let's take a look at how this works in our scene. Okay, so now if I left click on a sphere, you can see a new material, a decal gets applied to the sphere. And you can see they are being randomized. So we have the red, the blue, and the green. And you can see they conform to the shape of the sphere. So that's why decals are very useful for this. So now we have our decals applied to the sphere. Now what I want to do is every time I left click on this, I want to mimic the effect of an impact applying force or an impulse to the sphere. Let's take a look at how we can do that next. Okay, going back into our if statement, right below where we created the decal material, we're going to add in an impulse to the object that we hit. Now we know that we're looking for the object of sphere, so we know that it has a physics imposter. What I'm going to do here is I'm going to say raycast hit dot picked mesh dot physics imposter dot apply impulse. Now you could also apply a force to this. Now, if you remember from a previous video, the force value here is essentially the direction that we're applying a force to. I want to use the direction of the raycast to determine the force that we're applying to this sphere. The raycast direction can be used to determine the force direction. I'm going to say ray.direction. And then the contact point is going to be our pick point. Now remember, the contact point is where we're actually applying the force or the impulse to this specific object, whether that's the center point, the top corner of that object, the bottom, so on and so forth. In my case, I want to apply the force along the picked point. So we're going to use raycast hit dot picked point. Okay, remember, pick point is a vector 3, and so is the ray.direction. Okay, so far so good. Now we are going to have an issue in a moment. But let's just see how this works so far. Okay, left click on the sphere. You can see this get pushed back, but as you can see, the texture is now floating in the sky. So what I want to do now is I want to make the texture a child of the sphere. So every time we apply a texture, we need to ensure that the parent of this texture is now going to be the sphere. So as the sphere moves, we're then going to be applying that texture as a child. Okay, going back to our code, after we assign the material for the decal, we need to ensure that the decal stays with the sphere. And to do that, we need to make sure it's a child of that sphere. So we'll say decal dot, and there are a few ways of doing this, but we're going to use set parent. So set parent will allow us to use the original position of that decal, but then use the sphere as the parent. So they'll both move together at the same time. And I'm going to use raycast hit dot picked mesh. Now, if you use dot parent, what's going to happen is that the decal may move, so it's now part of the sphere. But with set parent, we don't actually move the decal, we just assign the picked mesh as the parent. So let's give this a quick test again and see how this works. Okay, so now if I left click on this object, you can see that the sphere now moves with the decals. All right, let's go back into our code. Let's add some more mass to this object so we can play around with the amount of force we're applying to the sphere with our raycast. Okay, going back into our create imposters method, go down to the ground. I'm going to replace the restitution with friction, and I'll bump that up to a value of 10. Go down to where we created the sphere imposter. The mass is set to 0.5. I'll bump this up to a value of, let's go with 20. And friction we can leave at 1. All right, so with those changes, let's take a look at how much force we're applying to the sphere now with our raycast. Okay, so I'm going to left click on this, and you can see it does still move, but now it's much heavier, and I can apply multitude of materials to this. Now, if you want to apply more force to this, we can go back in and take a look at that as well. So remember, with the apply impulse, if we provide the ray dot direction, we can also apply a dot scale to this to increase or essentially add a multiplier to the amount of force we're applying to this object. So I can increase this to a value of say 5, and now we're multiplying the value of the ray dot direction by 5. So now we're applying more of a force to the sphere with our raycast. Okay, so if I left click on the center point, we're now applying more force to this. And now you can see that the decals are sticking with the sphere. Okay, so there you have it. That's how you can use a raycast to apply an impulse and apply decals to a sphere object.